this video we are going to cover our first lesson on the Arduino microcontroller. So this is our first lesson. Let's begin. So breadboards, why are breadboards called breadboards? Basically is a piece of wood for putting bread. So people will go to the kitchen and take out this breadboard because it's a nice piece of flat wood that they can actually use to secure components onto the board for prototype. So that is why this thing is called a breadboard. Okay, so it's used for us to create prototypes, and how it works is that at the back of the breadboard there is these metal stripes. So the horizontal stripes don't bridge the gap and connect only 5 of these. So this 5 is not connected to the other 5. So A to E is not connected to F to J, and but the plus and minus is connected all the way to the end. So if you look at your breadboard, okay, it's actually secured with this double-sided foam tape. So if you actually peel it off, it will actually show you, you will see that metal stripes. But don't go and peel off this double-sided tape unless you want to mount it onto something. So let's continue. So in your simulator, there are 2 ways that I like to set up. So this is setup A. This is my preferred way of setting up my Arduino and the breadboard. So you can see that there's this 5-volt power. It powers the prototype. So it will connect to this, and then the positive connect to the plus and goes to the top. So it powers both sides of the board. And then the negative, it also connects to both sides of the board and goes to the ground. So that's setup A. And then there's setup B. Setup B is provided in your Tinkercad. So up to your preference. If you want to use setup B, it's already available on the project, so you can actually just use it. Unless you want to use setup A, which is what I want to use. Okay, so next we want to talk about LED and resistors. So LED, it takes up about 2 volt. It depends on the color. Okay, so the red bulb takes about 2 volt. You can actually Google for LED bulb resistance or resistance. So probably you will find a chart. I think you'll probably find a chart around that explains to you the resistance. Okay, so maybe look at this. Yeah, I think resistor calculator. So it shows you different color actually takes up different resistance. So I think you can go and look through it. But most bulbs, we just take it as a 2 volt. So there is a long leg and a short leg. So the long leg is actually positive, and short leg is negative. And you look at when you look at this this video, you take out the bulb. Just take out one of the bulb from your bag. Okay, and you can actually see that the legs are, all of them will have a long leg and a short leg. Okay, it's not that the factory cut wrongly. It's actually intended to be like this. Okay, so next, the resistor. Okay, in your box there is a bag of resistor. There are 2 different types of resistor. So this one, okay, so this resistor, you can see the color is double orange, and then 2 black and 1 brown. Okay, so this is a 330 ohm, double orange, double black and 1 brown. Then in your box, the back of resistor, there is another one. Okay, so this is actually a 10k ohm resistor. Okay, so it's a different color. As you can see and compare, they are different. Okay, we're going to continue. So when you take it out, okay, you just need to pull it out, and then after that you should bend the legs of the resistor. There is no positive or negative side for the resistor, and just plug it in. Next, so how do we know the resistor value? You want to read the resistor value, you must use this chart, okay, or you can go and memorize it, the resistor color code. So we are using a 5-band resistor. Some in the market is a 4-band resistor, so we are using these. So how do we actually tell? Is using the band. So first band, the color tells you the number. Second band, second number. Third band is the third number. So is based on these numbers. Then there is a multiplier. So you multiply by the number here, you will get the value of the resistor. So for this example, red is 2, orange is 3, 2, 3, purple is 7, 2, 3, 7, multiplied by 1. 237 multiplied by 1 is 237 ohm. And the last one, brown color, is plus minus 1% resistance. Okay, so the tolerance is plus minus 1%. So so it is not accurate. Okay, it's not accurate. There is a difference in the tolerance. So is plus minus 1%. So the one that is inside our box, the orange, black, brown. So what is the value of this? If we look at the chart, first one is orange is 3, second one is 3, third one is 0, so 330. Black is multiplied by 1, so 330 ohm. Okay, so 330 times 1, some is times different number, so depends. And then after that we have a fifth stripe that is brown, then is 1% tolerance. Okay, so if we look at the other one, there is the other one in the box that is okay, brown, black, red, brown. So it's brown 1, black 100 times 100. 100 times 100 is 10,000. So 10 kilo ohm, 10,000 ohm, 10k ohm. And then the last one is a brown, so it's plus minus 1%. So you can see from my video here. Okay, so you can see from here, brown, black, red, brown. So it's 1, 0, 0 times 100, which is 10k, and then the other one is also brown, is plus minus 1%. Okay, so that is how you read the resistor value. Next, okay, so safety advisory, unplug from power source before assembling your circuit. Always unplug it. Don't while it's powered then you start to build your circuit. Okay, so you may destroy your items, okay, your components. So test on simulator and check twice before you plug into the power source for the Arduino. So always test on simulator first, check with your simulator, and then you can try out. So first circuit that we're going to do, okay, we are going to start on this. So go to your Tinkercad, and under circuits you click on create new circuit. Then we will use Arduino. Okay, press the keyboard R, or you can use this to rotate. Rotate is R, so R. Then take out the breadboard small. Then we'll connect the 5V to the positive. Then we will change the color to red. So color is important. Red is for the power, so you should change it to red. Then we have another one to the ground, so this is black. Okay, so double click to create the joint for the to bend the wire. So okay, hold shift and you can actually select 2 points and drag them to a nicer position there. So this part is done. We are going to zoom in, so you can connect this portion if you need this portion, but I'm not going to use it for now. We are not going to do any programming for now, so we are just going to look at this side. Now the LED is it takes up 2V. So how do we actually calculate the resistance value needed? So actually, if you look at this Arduino tech spec, you can actually see that the IO pin, input output pin, is actually 20 milliampere. So if we take these 20 milliampere to ampere, okay, we will see that it's 0.02. And in the previous lesson, we know that voltage over ampere, you will get the resistance. So how do we actually calculate? If you take the so if we open up terminal, okay, so we look at these. This is actually 5V. If you look at this, it actually tells you that this is actually 5V. And then we know from here, if we go back to the previous slide, this 2V. So 5V minus 2V. So you take 5V minus 2V, you get 3V. So it only can take 2V, and we are left with 3V. Something must take the 3V. If not, it will actually burst the LED. So if we can actually try this on simulator. So if we take a LED, so the same thing, the LED, this is the long leg. Okay, this is the long leg and this is a short leg. Okay, so we can take this LED, plug it in. So if I connect these to here, red, and I connect these, black. Okay, when I switch on, what will happen? It will actually burst. So so it tells you that LED is current through the LED is 483 milliampere, while you can only take 20 milliampere, which is 0.02. So how do we actually calculate the amount of resistance? So we see this 5 minus 2 is 3V. So 3V divided by ampere. So just now we know is 0.02 ampere. So we divide by 0.02. So the optimum will be actually 150 ohms. So if we change these to 150 ohms, so you take a resistor, okay, and you plug it here, you change the resistance to 150 ohm, start simulation, and it will light up. If you change these to maybe 140, okay, there will be a warning for you that the life of the LED will be reduced. So if we change these to 150, okay, that's the best. The one in our box is 330. Okay, so as long as the number is bigger than 150, it should be okay. So so we are going to use this. So this is our first circuit. So this is done. Maybe you want to label it. So click on the stop the simulation, put a label. Okay, so you can right here this 330 ohm. Okay, next. Okay, so we are going to do another one. We are going to use put in a button with the LED. So the button, how it works is that let's take out a button first. So this is how the button looks like. So if you look at this button, it is two pointed upwards, and the other two is pointed upwards too. If we look at our real button, okay, we look at our button, it is also like this. Okay, so there is the claw. So this is how it looks like if we just rotate it. So the button looks like this. Okay, so this is how it looks like. Next, so the button is usually put in the center. We should put it at the center. So I'm gonna put it here. So next, so we can follow these or we can swap around. Okay, I think I'll just follow this. So then we can Command C, Command V, and you can copy and paste. Command C, Command V, copy paste, change the color to maybe blue. Then we Command C, V, and put it here. So this is like this. So when you press down the button, what it does is it actually connects these 2 points. Okay, terminal 1A, terminal 2A. So these two will be connected. This is one piece of metal, so it is always connected. This is also connected. So but when we press here, it's actually to connect these two. Okay, these two. So when it's not pressed, the circuit is not closed, so it will not light up. Okay, then we will put one wire here, and then I'm just going to change this to red 2 and this to red. Be good. So next, so when we start simulation, okay, so this one is lighted up. When you press this, because when you press down, these 2 points is connected, the 5 volt goes up from here to this row. Okay, so the 5 volt is powering the entire line here, and when you put it up here, it will connect this. So when you press it down, it will actually go to here, and then it will supply this LED with power. Okay, next we will look at the potentiometer. So this is a potentiometer, is like a knob. Okay, so we will just look for it, potentiometer. Okay, potentiometer, then we'll just put it here. Okay, so the potentiometer, and then we will put in an LED. Green. Now if we look at the setup, okay, look at the hardware. Okay, so potentiometer that is given to us is that's inside the box is 10k ohm, so you should change these to 10k ohm. Okay, so 10k ohm. Then the next thing is we are going to copy this, paste. Okay, make sure you put it on the right position. Okay, this is quite a common mistake, not only for simulator but on the real circuit, that people will actually plug in on the wrong side. So if it's on 12, you should plug in on 12. Then this will be connected to these should be connected to the center leg. Okay, so these two is for one is for power, and another one is for the ground. So we will just connect these to the ground. Okay, and so this one is black, and then this one is red. Okay, so just like this. Okay, so we have one to give it a variable power. So this is green. Okay, so when we start simulation, it doesn't switch on. This one switch on. Okay, so when we it's like this, it will not on, but when we turn, as we turn, it will actually supply more power to this LED, and then it will light up. Okay, so this how the potentiometer work. Is a variable resistor. Okay, so next, so this gives it power. This is to the ground, and then when you rotate this, it changes the resistance and supply a different amount of power to this LED. So next we are going to do the last one. So the last one is to have a LED. So we are going to use for this, we are going to use yellow. And then we have another resistor. Okay, and we have this light, okay, photoresistor, light dependent resistor. Okay, photo means light. So we're gonna put this here. So this resistor is sensitive to light, so we are going to use this. So this is just, there's no positive negative, so you just need to plug it in, and so I'm going to put this here, change this to maybe yellow. No, I'm going to change it to red then. Red. Okay, I'm going to change this to red. Okay, so we're going to start this simulation. So what happened is that if it's the dark, just adjust this. So if it's dark, no light. When it's bright, there is light. So when it's brighter, lesser resistance. When it's dark, high resistance. Okay, so that's it for this circuit in the simulator. Okay, so nothing explodes. So we are going to start to build on our hardware. So let's start. So this is the breadboard, and we are going to start. So take note of the LED. Okay, so the LED, long leg, short leg, make sure you know where to plug them. So we are going to plug it positive leg on the right side, and negative leg on the other side. I'm going to just plug it in first. Then take out your 330 ohm resistor. That's the only resistor that we are going to use. So take out one. Okay, and then you flex the leg. Okay, bend it 90, and then we plug it in. So make sure you plug it into the right places. Okay, so this is so my LED is on, the leg is on 3. Okay, and I plug the resistor to 3, as you can see. Next I'm going to have to use so the jumper wire. Okay, so make sure you take out the male to male jumper wire. So this is the jumper wire that we want to use, the one that has both sides is male to male. Okay, so take out one of the wire. Okay, and plug it into the positive and plug it to the other leg, positive. Okay, then next we are going to put in another LED. So this time around we'll plug in the green LED. Same thing, I'm going to put my positive on the, okay, I will plug it here, positive on the right. Then I'm going to take out a wire. Okay, and we are going to plug in we need to take out another resistor. Take out another resistor. Okay, bend the legs and make sure you are using a 330 ohm. Okay, so I'm using a 330 ohm as you can see, so maybe zoom in. Okay, then I'm going to have another jumper wire. Okay, let's just maybe plug in the button first. So make sure you plug in the button correctly. So you just plug it beside it. Okay. Okay, good. So I have it fixed. Okay, so I'm going to just plug it. Okay, and let's have another one. Okay, sorry, this should be plugged into positive. Okay, so like this. Next we have so next one we will have is, maybe you should just test it first. No, you're gonna let's just test it. So we're gonna have another two wire. Okay, so two wires, one for the positive, one for the negative. So this one, plug it to the negative. Okay, plug in the negative for the purple. Okay, so this is on the negative, and we'll just plug it onto my ground. Okay, then another one to plug to the positive. Okay, so can actually, I think you can actually see that let's just take a look. So you can actually see the 5 volt. Okay, so 5 volt, so this is connected to 5 volt. Okay, okay, so make sure it's connected to 5 volt, and another one is connected to ground. Then we have this. Now we can plug in the power, so we are going to plug into the USB-C. Okay, so when we plug in, so there is power supply, and then when we press the button, the second LED lights up. Okay, so this works. Okay, so we are going to continue. I'm going to just unplug. So unplug, and we will continue working on our circuit. So let's go back to here. So next is potentiometer. So the potentiometer, there is these three grooves here. You must take note of the grooves. So these are to tell you where are the pins actually. Okay, so these are actually tell you the pins. You can see from here, this 1, 2, 3. So when you plug in the time, these 3 legs, you can actually see the 3 legs, right? Also, you plug it in, then you can wire them according to the simulator. So let's just do this. I like to plug these facing me. Okay, so I'm gonna just do this. Take note that when you plug in this potentiometer, right, make sure it's on the same side. And when you plug in at time, there may not be a lot of space for you to plug in the wire, so you need to squeeze them. If not, then maybe you may want to utilize the other side so that you can have more space. But utilize the other side. Yeah, you may want to utilize the other side for the space. So if we want to do that, then we will plug it here. Okay, then we can actually from there, so we will just so this is how it looks up. Okay, so this is how this looks. Okay, then we can actually put a wire to jump over. Okay, so I'm going to quickly go and plug in the other LEDs. So same thing, the positive and negative, you make sure that the positive leg, I will put it on the right if you are wondering. So let's quickly go and plug it in. Okay, then I'm going to jumper wire. Okay, so positive. Yeah, I will jump it like this. Okay, depend on how you want to do it. Okay, so next. Okay. Next, I use a yellow wire to connect to the LED. I'm missing one wire. I'm going to plug in the last wire. So it's going to be here. And it's going to go to the, okay, sorry. So I changed the setup. So okay, so this is just like the simulator. This is going to the positive, and then this peach color is going to negative, and then we have this to the LED. Okay, so later we are going to light it and test it out. I think maybe we should test it out now. Okay, so I'm going to just plug that in. Okay, so power supplied. Then when we press the button, the LED lights up. This we can actually hold on. Actually turn the potentiometer to reduce the brightness. Can you see the hold on? So from here we can actually turn to increase or reduce the brightness of the LED. Okay, and so the potentiometer works. We're going to work on the last one. Okay, so the last one is using the photo resistor. The photo resistor actually looks like okay, it looks like this. It has that S, the stripe on the top. Okay, so it has two pins. Okay, doesn't matter positive, negative. So I'm going to plug this in. We're going to have another LED. Okay, and last, we'll plug in all the wires. Okay, I'm done. I'm going to I'm just going to cover this first. Okay, so I'm going to cover this up, and I'm going to start powering it. Okay, so if this is just zoom a bit. So if I remove, you see that it lights up. If I cover, it switches off. Okay, remove again, lights up. Okay, and cover it, switch off. Then so now this the complete circuit. Okay, button, and the potentiometer. Okay, so that concludes our first lesson on the circuit. So we didn't do any programming. We only use the components on the in the box to create these LED lighting up. Huh? So that's it for today. Thank you.